Hi, everyone. I'm Ina Fried, Chief Technology Correspondent at Axios. I do know that we're standing between everyone and the networking reception, but I promise this will be the best 4 hours of the day. No. So I'm gonna do my best to have a conversation on how do we bring energy efficiency into all this. And it's a super complicated task because there's obviously a million parts to the wireless ecosystem. There are different approaches you can take. And before I get to 6 people who can intelligently answer the question, I thought I would turn to the absolute worst, least power efficient way to answer the question. So I asked ChatGPT, how can generative AI help the telecom industry save power? And it suggested optimized network routing, predictive maintenance, energy consumption modeling, infrastructure deployment, cooling systems optimization, and load balancing. By incorporating these AI-driven strategies, telecom companies can enhance their energy efficiency and contribute to lower carbon footprints. So I think we can all assume that that is the floor from which we can start to the discussion. As I think our generation's new task in life, we all have to prove that we're better at our job than ChatGPT. In general, I find that to be a manageable bar, but I am a little worried that 2-3 years from now it won't be. Fortunately, we're having this discussion now. Since we are talking about so many different parts of wireless, we have folks that deal with chips, we have folks that deal with data centers and everywhere in between, I thought what might be helpful is to sort of introduce yourself, but kind of explain where you're coming at this energy efficiency. You don't have to outline your whole strategy, we'll get to that, but kind of explain where your work is so that as we're having this conversation, folks are a little bit grounded. And Tiago, I think I'm going to have you go last since you're kind of doing the overview. So why don't we start at that?
Thank you, Ina. Samir Vuyyuru, I lead the telco vertical for AWS. So my customers are all the MNOs, the wireline operators, the communication service providers worldwide. And it has been a very recurrent theme, especially in the last 3 to 4 years, that energy costs are just being prohibitively impactful to the income statement. I was with a board of directors in Europe who said their energy bill had gone from 50 million euro to 300 million euro in the space of 6 months. So this is real, and we are doing everything we can in our power. We'll talk about it today to help in any small way we can.
All right, I'm Babak Jafarian from Aira, coming from wireless background, and as you guys saw some stuff from Aira, the reason we are here because of one of the applications we have, which is our app. It's really utilizing the whole AI ML to create that optimum solution and saving energy. And I think I didn't like ChatGPT answer. It should be contact Aira or someone in Aira. So I think someone needs to add that one to this. So by the way, that's who I am.
I'm Sindhu Xirasagar. I manage all the product management for all our RAN software solutions, both on the traditional RAN and the Open RAN side. I'm going to today look at energy efficiency from the perspective of SAN, really. Right? Like, what are the platforms on which these software and AI runs? How are we going to implement all these grand things we've talked about in a platform in which you can run it efficiently, and you're not really adding cost to it or power to it that you're trying to actually take out of the system. So that's part of what I'm going to talk about, and also I'll give you some examples of where we have applied AI and run some initial POCs with partners, as well as in Intel labs that Udayan talked about, and then we'll talk about what gains we are seeing there and the promise of it for energy efficiency, especially in the DU itself.
I'm Gwenael Poitau, Wireless AI Technology Director at Dell Technology, as part of the CTO office. And one of the research programs that I lead is on network energy efficiency. So we try to look at that from a holistic point of view, so really from the physical layer up to network management, the cross-layer optimization, as it has been mentioned already today. So it's a multi-agent system with multiple decisions that to cooperate, to work together in order to reach that objective. And we'll discuss that, I'm sure, in details.
Hi, everyone. Tiago Silveira. I'm an associate partner in McKinsey. I'm not your typical management consultant, even though today I look very smart in my suit. I'm more often found with my boots in, visiting some mobile sites in the jungle of Colombia or something like that. I come from an engineering background. I have a PhD in telecom. I've worked in the industry for 14 years in Siemens, Nokia. And then I joined McKinsey. My life in McKinsey is how to help operators create efficiencies in their network domain. And I think more specifically to this panel, I'm leading our energy for operators practice in McKinsey. So a lot of the work I've been doing in the last years has been helping operators reduce their energy bill, or in some other cases, just flatten their energy bill, which is already quite a challenge, as I think we've seen from your comment, which is very, very real. Energy, we will go into detail. From the operator's perspective, is today one of the highest areas of concern when we talk about bottom line, giving the sheer volume of costs it's involved.
So I want to start by kind of painting a picture of what's possible, and then we'll go through how we get there, making sure that we don't, save one kilowatt by spending a watt of energy and all that sort of thing. But again, I think to start things off, I want to open it, paint a picture in each of your areas of expertise. Where can AI and specifically generative play a role in improving energy efficiency? What would that look like? How significant might it be? And I'm again going to start there, since I think you might have the broadest answers.
Yeah, so here's how we look at it at AWS, right? So there's 3 layers to our approach to energy efficiency. The first one is infrastructure. So we have invested in building our own silicon. And as an example, NTT Docomo publicly shared a month ago that they reduced their energy consumption on their core, not the RAN, by 70%, just by moving from the existing infrastructure to our own custom-built silicon. And we're doing that for training the models as well. So we have what we call Inferentia and Trainium, in addition to Habana Gaudi, in addition to the NVIDIA instances. So there's choice as to what you use. The second one is, historically, in a vertically integrated supplier environment, which is what the CSP universe has been used to, the hardware was the hardware with heavily tied in software. You could not realize any improvements as they manifested themselves in the industry. So we started putting together an ecosystem of partners, among which are multiple foundation models that are tuned specifically for the telco industry, Aira being one of them that's using it, and then creating an application layer on top of X apps and R apps that can be deployed anywhere. So that's how we look at it. And in terms of what's possible, let's do the math. If we just generate a 20% reduction in power, depending on the country, that's anywhere between $500 to $1,000 per RAN site at this point. In the United States, each operator has roughly 100,000
a month.
Mm-hmm. Correct. Yeah. So that's $100 million of savings just by a 20% increase in energy efficiency. So that's the art of the possible, and it's within reach today.
And I want to dig in, because you do have the expertise of kind of where in your stack does it make sense to target. But maybe I'll come back to that after we've heard from everyone.
Yeah, I just want to add to what Samir mentioned, that just to set the context, you're talking about 2% of worldwide energy consumption is just going to telcos. And when you focus on that, it's about 60-70% of that is towards the RAN. Now, again, going deeper into the RAN, you have newer components, anything from DU, CUs, virtualized one. But out of that, the radios are still the whole. They're going to burn as much as they want. And that's overall. So while other people looking into the processors and everything, in Aira, we thought with AIML, we can target that part initially, which is the most important part. But in general, this problem is going to extend. If you look at the 2G to 3G to 4G, 5G, in every G, overall energy consumption is going higher and higher. We do, again, as a part of ORAN and 3GPP, we do our best to reduce the energy consumptions per bit. Let's be honest, we do that. But the total amount of bits is going up dramatically. So from carrier aggregation of 20 to 40, going all the way to 200, going to 500. So the total amount is going higher and higher. And then you said what we do, again, what I see and coming from that side of the story, we have tons of information. Now, why is AIML? We have tons of information, KPIs, counters, all of the stuff that we developed and introduced. I know there are some operators here. Let's be honest, we use about 5% of them, maximum 10%. Majority of this information is already there, ready to be cooked and used. And that's the power of whole AIML that we can bring to the table, utilize and unleash this type of information from that huge amount of data and use it. Data is king, so let's use it while it's there. So that's what we believe in Aira. We have done it, we showed it, and I think that's the path going forward.
Sindhu, obviously at the chip level, it's influencing from how chips are designed to what those chips do. Where do you see the biggest opportunity?
So one of the things that Aira is doing, for instance, and we talked about, is how do you do power, basically minimize the power consumption of the radio. And we do have at the DU level, the layer 1, layer 2 level, we have a ton of information. You can get user level information, cell level information. So one of the things foundationally, you have to ensure that you're virtualizing the entire RAN. And the reason is, somebody said earlier, the most, the killer use case is one that we don't know about, right? So which means that you don't know really what data you need from the system. So virtualizing all the way to the layer 1, really making the software-defined network is, we think, critical to ensure that it is future-proof, really, to unleash all this. So that's point number 1. Point number 2, I think you have to think about, so you're going to be executing different models. You're going to be changing. You're going to be training them on the fly, getting new models and so on. You need to be able to, you have to adopt cloud-native technologies like now, right? I mean, we have this Open RAN stuff, and you can't use the old static way of doing things if you want to flip models and so on. And then, like I said earlier, you cannot spend more, cycles than you're saving, really. And that has to do with the silicon platform. So what we have found, especially in these DU algorithms, these are not like huge large language models and all that. There are many, many small models instead. So you have to have the silicon and then the platform above it to be able to support, scheduling these different algorithms when you models when you need to be able to train them. Not that often, but sometimes like in minute or 2 minutes kind of things. And then the other thing about these models is they have very few parameters, really. You're not looking at like millions of parameters. You're looking like tens of 20s parameters, right? So in those cases, what you don't want is like an elephant AI chip. What you want is the chip that you're already using for your new stack, that should be able to run all these AI models. And so what we have done in the Xeon processor is exactly that, right? So we have ISO optimizations for running the DU stack, but we also have AI capabilities built in there. So that balance is something that you have to constantly look at when you buy the silicon as well, because that is going to give you really the bang for the buck at the end of the day.
And Gwenael, you're kind of in between. You're not at the chip level. You're not at the entire data center level, although there's a lot of your components in there. What?
Yes, and it depends. You you have to buy the right chip.
Right. Well, I was going to ask, Gwenael, like where do you see the biggest opportunities for power saving?
So,
Oh, that was first one. Yeah.
so for power savings, we have seen with link adaptation itself. We worked with, Capgemini on this. With link adaptation itself, we were able to show 12% spectral efficiency saving. Agreed, this is not the operating data set and all that, but still it is substantial promise here. We have done some work on user selection in the MAC layer, and we have found tremendous improvement and reducing the amount of cycles as well. Not just, just the CPU cycles used, in addition to the power savings that we are finding due to throughput improvements and so on. So there are all these MAC layer things, and then there are the layer 1 things that are being investigated, the channel estimation and those kinds of things as well that are showing promise. So I think, we're trying to solve this whole problem of, hey, all the ecosystem needs to come together. We have to make all this work with the rig and all these things, right? Which is all true. We have to do it because you're going to get a lot of benefit in the automation level. But just at the RAN management level, with what we have today, with just a few players, we can do a lot today, right?
And I wanted to
Yeah, so if we take a step back, when we discuss with service operators, the average network load is about 30-35%. So it means that you have a lot of those opportunities indeed to save energy. And while they're not satisfied today, despite the very large number of projects in the last 15 years on that problem, because it's not a new problem, it's an increasing problem, but it's not new. It's because the legacy techniques are usually rule-based, so based on threshold, you will take some decisions, and that don't address the diversity of use cases that you have today in terms of the network topologies, the traffic conditions, the mobility of the user, of the different user equipment, and so then that's why we need those new data-driven capabilities. And in terms of the complexity, in addition to the different network conditions, you also have multiple decisions through the stack layer, and those functions have to work together. And that's what is not obvious. They should not compete with each other. We know that the main source, as it was said, of the power consumption is at the power amplifier. It's even worse, of course, in massive MIMO. But that power amplifier, if you want to you want to maximize the opportunities to switch off those power amplifier. So you have to work on the cellular policy, basically, to create those opportunities when you are not at the peak traffic to switch off those power amplifiers. But the scheduling policy is also driven by your policy on the admission control or the traffic steering, which comes from the network intent, which will be quite different depending on the type of traffic and the type of network that we deploy. So that's, again, I think that's how we should see. Indeed, we have some specific XAPs to develop for each of those functions, but we also have to work at this multi-agent framework and how it will work in a scale deployments so that you can reach the final peak.
Tiago, again, everyone else on the panel is sort of looking at one piece of this. What, from your perspective, what hasn't been brought up, and also you're looking at that whole ecosystem, where are the biggest opportunities maybe that we haven't talked about for saving power?
Yes, but maybe one completely different look to all of this. If you ask me, if tomorrow you go to an operator, what's the one initiative you will do that brings the highest value with the lowest effort? And I bet no one will guess. Increase 1 degree in your air conditions of your site. This is the one initiative. This is the first initiative we implement with any operator. And it may seem easy, it's not.
So is that running 1 degree hotter?
1 degree hotter,
yeah.
The air condition. Now, taking a bit a step back, if you look into an operator today, energy will be about 3% over revenues. So that's 3% margin just there on energy. And we've seen indeed in the last 2 or 3 years, the total cost with energy rising between 50 and 80%. So that means yet another percentage point has gone away with margin. Now, why is it such a complex problem? And there's a number of factors. One is even for a tiny country like Portugal, where I come from, one operator will have 6,000 sites in the network. Those are 6,000 scattered entities that have been growing in the last 15, 20 years. Often operators will be the result of mergers and acquisitions of different entities. And operators are also very often managed centrally. And often nobody knows what's on those sites. So why is this 1 degree extra in the temperature something key? Because operators often don't know what's the temperature on those sites. We've run a survey with some operators. We will be coming out with an article soon on that. Only 50% of the operators have site level energy management, like smart meters, for example. 50% know how much a site is consuming from invoices.
And are you typically just flipping up the temperature 1 degree without needing to change what's inside? Or are you having to change what's inside in order to run it 1 degree?
No. Normally what we will do is, normally this is something we will do together with the OEMs. Of course, nobody wants to have the site running alarms and having service failures. I mentioned that a bit more of a provocation than anything else, but definitely this is one of the initiatives. When we run transformation programs with operators on energy, normally we are looking from between 20 to 30% of emission on reducing energy. And we will be looking into something like 20 to 30 initiatives across the spectrum. This will be one of them, but there will be many, many others. Now, if you ask me, what are the areas where we see AI, or I would say data in general, helping, is the first is understanding what should be the normal consumption for each of these individual 6,000 sites or 100,000, depending on the country, right? So having models that allows you to forecast, depending on what's the equipment there, what's the outside temperature, what's the altitude, what's the humidity, what's the traffic, models that allow you to, with some accuracy, forecast what is the normal consumption or target consumption for this site versus reality. Already this is a huge asset. If you think of countries where there are cases of energy theft, for example, you don't know if your site is consuming a lot because you have a lot of equipment or because your neighbor is stealing energy. I mean, it's kind of an anecdotal example, but it's something that I've seen firsthand. So I would say one is understanding through data what would be the right level or the normal level of consumption for a site. I think that's one. One big second one, even without entering in all of the complexities that we were just discussing, which are very much relevant, is operators will be very, very cautious, and we have these discussions daily on doing radio shutdowns. Why? Because you have all of these UCLA measurements. Everyone wants to be the leader on speed, and operators are very, very cautious with losing that edge. Now, what we've seen has a lot of impact is understanding how does 1 megabyte per second extra represent in terms of actual user experience, and then translating this back to kilowatts. So it's kind of getting this relationship between 1 additional kilowatt hour and something that's measurable in user experience and financial derivatives of this user experience. Either it's churn,
and
customer acquisition.
Is it usually that last little bit of speed is the least energy efficient also? Like, is there some good savings at the top, if you will, by just saying, well, obviously if we optimize for speed, we get, X higher, but if we optimize for energy and performance, you give up this, and how willing are folks to learn from that?
We see, so I think there's a journey that we are seeing with our clients in general in the industry. I would say if you'd asked 3 years ago, no one would want to do it. So we would have like the basic level of OEM features shut down between midnight and 6 a.m. This would be the level of discussion we would have some years ago. We went from that into, let's extend this window, bring these thresholds a bit more dynamic. And now I think the latest we've been discussing is, no, let's link this more with actual user experience. Let's bring AI so that we have on a per site level the right decision based on the actual customers you have on those sites, and what is the usage or what are the use cases these customers are taking from the network, right? And how much value they are creating.
So if these are the best things that everyone has to bring to the table, I'm curious, did you want to jump in before?
I absolutely want to jump.
Okay, jump in and then I'll jump.
Let's talk about AI, two types of AI. The first one is ancient intelligence, aka common sense. Right. Which is, I was with a carrier, said, I'm still operating my 2G network. I asked why. They said, well, we've got this contract for a device. I said, which device? Kindle. I was like, so we're responsible. Why didn't you move all your 2G network to the cloud? And just, it's not going to be a quality of service issue. We will provide a path through the cloud into Kindle. Retire the old networks, move them out to the cloud. They're operating at 5%, 7% capacity. And you got this huge data center serving them. That's archaic intelligence, right?
Yep.
And then on the other side, I actually disagree with Gwenael and Sindhu here. I think those parameters are necessary, but we're missing the whole potential of Gen AI if we limit ourselves to that. The beauty of Gen AI is you don't know exactly what data it's been trained on. It is app usage data. It is avatars encoding versus Charlie Chaplin's films. And Gen AI has the capability to use all of that intelligence. But you are saying that at the edge, it's not deployable, but it is. There is something called quantization and pruning of these Gen AI models that allows you to deploy it at the edge without losing that power. So I think we got to get out of this telco-centric model and really look at what is consumer behavior, what is enterprise behavior, what is app behavior, what is machine-to-machine behavior. That's where Gen AI comes into its own. Otherwise,
part of your point is that with Gen AI, it's hard to know
exactly
which
data
is going to be valuable.
Correct.
But throw it all in.
Correct.
Is there a risk, and I was going to ask everyone this, but I'm going to ask you first, is there a risk that because it takes a lot of energy to analyze all that, yes, you identify a few ways to save, but all that computational work costs more energy? Or are you pretty confident that even in a power-sensitive environment, doing more work will lead to more benefits? Because we do have this question in AI, and sometimes there's clearly no efficiency. We're doing it just for fun, not in the telco world, but in the consumer AI world. But then there's this question as we get into these enterprise deployments, making sure that we're actually getting the benefit. And so I want to hear both the pro and con.
The consumer applications are training these more.
Mm-hmm.
The incremental cost of training it with telco-specific data is, as the name suggests, incremental. Right? So it's not going to make an appreciable difference, in my opinion.
Does anyone else feel that there are better areas to focus? Because my next question was actually going to be, where's the wrong place to focus? And so I guess I want to ask that question, and if it happens to be there, fine. But if not, where are we getting distracted?
Maybe if I can comment on that, I'm not sure that we disagree. It's more about the timeline, I think. So I was saying this morning in the other panel, I see the solution as a continuum of options where in the short term, people have hard times to put a GPU in a DU or in a CU. So we are not there right now to use Gen AI close to the radio unit, for example. But I agree with you, with the evolution, at one point, hopefully, again, we will have better efficiency on that front, and we'll be able deploy that at scale. But still, again, it will be, in my opinion, hybrid solutions. Because in some cases, reinforcement learning agents or supervised learning agents will do a very good job for this task, and you will not need any Gen AI capability. In other cases, yes, having more data, having more depth about this data may help. I wanted actually to link also with what was said before about the benchmarking. Actually, even before deployment, I think we have a huge problem right now to be able to compare two different solutions in terms of network energy efficiency. It's really not straightforward. It's really easy on a radio unit to do that, but on a cluster, on a part of a network, really, because when you start to discuss about carrier cell switch on off, you have to move the user somewhere. They will disrupt another cell. So it's far to be straightforward, again, to take two solutions that are marketed in a perfect way and to say that solution is much better in terms of energy efficiency. So we started some work there, but I think even before deployment, in terms of design, given the complexity of all those techniques and again, the number of conditions that we may face, we need to do more work in order to have, at least in the lab, true ability to benchmark the performance. And then indeed, I fully agree, to follow that performance in the field in order to improve the situation.
I'd like to have a statement here. So, I know generative AI has its place in the places where you really don't know what all could impact an outcome, and you could have a very good outcome. For the areas that we already know, what are the parameters needed, right? I wouldn't go and waste a cycle on generative AI. So that is the difference. I think we have to use our natural intelligence to figure out for which ones you need this knife and for which ones you need that sword. And so we have to be able to parse that and figure it out.
So
one aspect.
While Samir's head is boiling,
one aspect to that. The second aspect is, you still have to backhaul all that data if you're going to just backhaul it for the sake of it. And I think we have to be careful about that as well, because that costs a lot of money, that costs a lot of energy as well. So you have to, I really think we have to take this in a more smart way, pick where you want to use, reinforcement learning or whatever works, and then where you're going to get the bang for the buck for generative AI.
So this is good. I hardly ever get on panels, by the way, anymore. Like, nobody disagrees. So I'm glad. Let me make sure I'm summarizing the different arguments right, because again, I apologize. I'm an English major. I don't know why you're not asking me to marry, but but if I'm understanding, your point is, look, we know the different things that go into power usage. We know where the power usage is. Let's look at those parameters and focus on those. If I understand Samir's point right, it's the whole benefit of generative AI is we don't actually know all the parameters. We don't know where we might get gain. And what generative AI is great at is taking all that data and suggesting what we haven't thought of. Am I summarizing each of your arguments very well?
Great.
Okay.
I think it's not that we know where the power is being used. We know the set of parameters that are going to give the biggest bang for the buck in controlling certain things. So when you already know that, then you apply smaller models and be able to get that benefit without having to go to generative AI. Maybe generative AI may give you that last 0.2%. Who cares? You're going to spend a lot of cycles on that, right? That's my view.
Yeah, Tiago, you start out with the point of, look, if we can run this 1 degree hotter, that's the single biggest thing we can get. Where you have a client who has, two very smart engineers with two very different opinions, it's almost as big a win as if you get to decide where the corporate headquarters should move. One of those decisions you really like. How do you help them sort through this?
Look, it's a complex question because it's a complex problem, and I think I do tend to agree with the Pareto of solving a problem, and that's why I started that's why I started with the provocation. I think we are still very far from those 0.2%, to be honest. Again, there's still some very basic problems to solve, because all of what we are talking here is very incremental, and operators in the US, they will be spending wireless, I don't know, $5 billion on. So at some point, there will be some new generation we will be deploying and it will stack on top of this 5 billion. What do we do with this 5 billion that's there today? What do we do? Well, in the US, we've decommissioned 2G and so on, but most of the countries actually still run 2G, 3G, 4G, and 5G networks. What do we do with that? What do we do with old rectifiers that are spending, percentual points of energy just there? So I do think, and again, I do think there's a role for data and for AI on it, but I do think we as an industry, we have to look into these low-hanging fruits before we go to those marginal gains. I don't think we are still there at the marginal gains in the industry. Now, of course, all of you here, I was there once. You're working on R&D, so you're working also on the next cycle and the next wave as well. And I think that's absolutely great. And again, I've done that for a great part of my life. But I think one of the challenges to the industry and all of us who work with operators is let's keep focusing on those $5 billion which are there. This is where really operators need help today.
I agree, but I just want to add to what you mentioned, that some of the discussion here, Samir was referring, putting the GPU and everything to this at the edge or something. This is really a little bit upcoming future, whereas there is something still there that AI/ML and all of those can help with the legacy networks. And I think that's the point that people needs to understand and bring it to the table. While that's going to definitely help, but still the same concept, the same blueprint can be used and bring from the legacy networks and in the future push it to the edge if you want. So I don't see these things contradictory, but I think the timing and the approach is different. How to approach the operators and let them absorb, use it, and then push it to the front of the...
Can I respond to it? Provocation. If you're talking about increasing a degree of air condition, of temperature in the air conditioner, get rid of the on-prem, move to the cloud. You're getting rid of many, many, many degrees, right? It's been proven now that a 5G network can run in the cloud and purely in the cloud. And there are proof points out there.
That's where I was going to go next. Yes, we've talked some in the other panels about O-RAN. Does it make sense to be talking about O-RAN? My sense is, on the one hand, there's probably different ways to architect that might be significantly power saving. On the other hand, if we're looking at a country like the US, I'm not convinced that's going to account for a big percentage of telco spend anytime soon. Where does O-RAN versus the way we've been doing it fit into this discussion from each of your perspectives, or anyone who wants?
I think I'd like to answer some of that, right? So Cloud RAN, we have to get there, and we can get there. But I think there are many, many deployments where I don't see you're going to backhaul all that to an edge. I mean, there is no edge there. I mean, edge is way back. So we have to look at those very practical, considerations as well. And the DU is going to be sitting right there next to the radio. You're not going to do it. So we have to take the solution that works for different areas, for different needs, and tailor it for that. You can use AI for everything, but you have to use it in the right way for the different things that you
need. As a person who lost half of the hair in the O-RAN, I'm going to lose the rest. But I just want to add to that. When you look at O-RAN, I guess that's, I've heard a couple of times people are talking about decoupling hardware and software. The whole essence was basically create those opportunities to pick and choose what do you want to do. I used to work in Ericsson. Hey, we had just a baseband unit. Ship it to whatever you want. Either it's at the cell or even indoor or something. So the O-RAN gives you that opportunity to basically pull and push whatever you want, that intelligence, and then use any algorithms or whatever you want to do, AI/ML or whatever else. So that's, I think, the beauty of this whole O-RAN movement. And it doesn't necessarily contradict what we discussed, but that's coming. I think that's the beauty of that.
And is there a risk in any of this that the AI benefits, like, I guess I'm curious, taking a step back from each of the specific implementations, do we think AI is going to have a meaningful difference here, particularly generative AI? Or, I mean, my sense is, again, you can use generative AI to do all sorts of things. I tried to use it to replace this panel, bad idea. And I, in general, trying to solve a complex problem by typing it in ChatGPT is not, from my perspective, the same as taking the benefits of generative AI and applying it to a very specific domain. What you guys are doing at the RAN level, what most enterprises could do by training an LLM or even using an off-the-shelf LLM and applying it to their data. But, you know, are we even using our own energy efficiency well to be talking about generative AI, or is it further off? Again, not that we won't have GPUs at the edge at some point.
So first of all, I think it's a fallacy that we need GPUs or high processing power to get the benefits of Gen AI at the edge. The GPUs are needed to train. And that happens in a central data center, which we call a region. People call them data centers.
Yep.
But the embeddings, the export of that, it doesn't need a GPU to run at the edge. And there is more than enough processing capability on existing, at least what we know of our RAN architectures, to run that today. You don't need extra co-processors today to get the benefits of Gen AI. So it's all about, let's train the model where it makes the most economic sense and the most power efficient sense to train. And then aspects of that through pruning or quantization can then run it on the existing RAN instantiations out there.
What are we missing in this discussion? It feels like there's a chance that we're, to some degrees, talking at parallel paths, but what hasn't brought up from each of your perspectives that's critical to understanding the problem we're trying to solve?
I'd like to come back on what you were saying on the impact on the quality of experience of the end user, because indeed, when we talk with the service operator, they are very reluctant to switch off anything, given that risk, and that's part of the problem. And indeed, because they don't understand what will be the exact impact, and that's where I think actually we can leverage Gen AI for that. Actually, so to link this decision that we take at the network level and the quality of experience of the end user, and it can go through again. Customer support, anything, a lot of data, indeed, that we will need in order to really understand the quality of experience. And thanks to that, we can be a little bit more aggressive on the decisions, because you know, again, what would be the exact impact. And in the end, that's up to the service operator to decide the best compromise. That will always be his decisions, but he will have the granularity to understand the impact of the decision, which is not the case today.
Yes. Maybe one point on well, we call it Cloud Run. Normally we call it X Run, which is this mix between Cloud Run, Open Run, and Centralized Run. And again, bringing a bit the discussion and being a bit provocative, where do we actually see energy impacts on such a transition? If you think what you can move to the cloud, it's only a small percentage of the overall consumption. Big part will be on the radios, a big part will be on the DU, and only a certain part will be on the CU. And then there's so much also you can centralize. Now, if you think on the openness of the interfaces and the level of innovation it can bring towards the ecosystem, I think that's actually the big unlock. Because today, the reality is, as much as we want to paint it, it's a very closed ecosystem. We know there's some players who are doing energy run optimizations. I would say generally limited adoption in the industry. Now, if we have open interfaces, then we can go exactly on this direction. How can we have tailored solutions for each operator for the specific conditions of a site level, a sector level? For that, we need a certain level of openness that's not there today. So my view, and feel free to disagree, is the big unlock there is openness and the innovation. We will do that. We will do that. Yeah.
I actually don't disagree.
And
Hey, stop that. What's standing in the way? In addition to some philosophical disagreement over where time and energy is best spent, what are the things that are standing in the way? I mean, it strikes me that one of the big things standing in the way is, for all we talk about Open RAN and Cloud RAN and stuff, that's not the way the majority of the world's networks are structured today. There's a lot of legacy. Are those the big impediments, or is there something else that we shouldn't forget is kind of standing between us and energy efficiency?
I can start and then the Pat. I think that's the valid point, that an energy efficiency method is necessarily either your legacy or Open RAN, that they don't contradict each other. But since we are in the AI/ML workshop, that part can be applicable to legacy also. How to use it and integrate it, that's a different matter. But you said what we need, at least a little bit selfish from my side. And 3 weeks ago, we had in face-to-face ORAN meetings. One thing came specifically for these energy management solutions. I heard just once or twice the word digital twin in the whole thing, that data is king. No doubt about it. Operators provide tons of data, and it's valuable for a specific type of AI/ML applications and everything. But when you go to specific scenarios, like, for example, energy management or any others, as a traffic steering, that you need information for the potential outcomes, that it's not business as usual. Where are those data? It's not like spam mails, emails, and the regular emails that you have tons of samples. In the telco world, we are very one-dimensional. We have data for everything is good. And credit to AT&T guys that they had good proposals that this is the value of digital twin. So that's not only going to operators to provide the data, which to me for a specific application probably is just 50% of the problem. Still, the 50% is the unknown. It's going back to companies like Vuyyuru and the people who can help to create and close the loop, that you have a really nice set of information to create all type of model, not just the specific ones. That's something I think needs to be addressed or at least discussed and socialized.
also maybe.
No, here.
So from my perspective, I think one of the things that we as an ecosystem fail to do is address the risks that operators feel at all this change, right? We're saying we're going to go do turn cell on off, we're going to do all this stuff, and we're going to do it very dynamically. In every TTI, we are looking at, sub-microsecond level. We're going to look at the data coming in, predict the, throughput, and then turn down processors to, manage the cells and so on. That is risky from an operator's perspective. And I think we have to figure out ways in which we can try some small things that we know, get into trials, work with them, and then hopefully they'll work with us, right? And then be able to show that it is not risky, meaning it will work, kind of a thing. I think that's where we're sort of stuck in my mind, that this is all very good, but hey, I have to manage the network and I don't want anything coming down, right? That stops the guy's headache.
I can go. And I think it links a bit to what you were saying. And I'm going to say, one of the big challenges we always face is, let's call it governance. And who owns energy in an operator? And the reality is no one or a lot of people will own energy. So there will be someone from some sourcing procurement organization who's paying the bill, someone who does sourcing of edging or PPAs. Architecture is making decisions on, what are the next solutions that are coming up. Planning is deciding where to deploy. Operations and maintenance are responsible for the equipment on the side. But who's the one that has the ultimate responsibility for saving energy? The reality is it's a very scattered decision, and no one wants to risk.
Yeah.
Right? So I think one of the things as an ecosystem where all of us work is being very mindful of the operator's situation, which is, I don't think it works with abstract solutions. We need to be very specific on a certain operation, on a certain operator, on their conditions. What is the actual impact for them? And then I think it circles back to what we were discussing. It's about understanding their data, understanding their customers, understanding their business, and how do we maximize this return per kilowatt hour that we are spending on the network. I think that's absolutely fundamental, of course, as well as technology. But we may have the best technology. If we don't work on this part, I think it will be very hard.
Tiago, that cycle needs to be broken anyway, because it's not a matter of energy saving. You know, operators, operational guys love to operate. Things are working. Why do I need to do anything?
Yes.
If it was up to them, we were at 2G, I guess, if not analog. But that needs to be that's changed in a way to some extent. But it's changing. The attitude is changing, and hopefully with some sort of I would say flavor from intelligence coming from AIM, a little bit flavors from ORANs and all of those activities that open up more, meaning a couple of operators that started ORAN, you give them a software, it doesn't work. AWS is there. We just launched another one tonight. It broke again, the bug. So that gives a little bit assurance to these guys that, hey, when you make everything software, it's a patch. It's not my baseband unit. So I think we are heading that way, but I agree that's difficult cycle to break. But
I think we might have solved that then. I think all we need to do is create something for the operations team that makes you run a 5G, 6G network, but translates it using AI so that to the operator, person doing it, it feels like an analog network. They control it as if it was the analog network, and it's running a 5G network.
That's a good analogy. So
We need to get generative AI to do that for us.
Yeah. So I'm going to suggest not that we end our discussion, but that we move our discussion. I'm going to posit that we'll all be at least 10% more energy efficient if we have the rest of the discussion over a beer or one. Or so. Yeah, Anand has a bit of a wrap up, but I want to thank the panel for an amazing discussion. Hopefully Anand has learned that he needs an engineer next year to moderate, but if not, I will see you all soon. Axios is doing an AI summit next week. If anyone's interested, just drop me a note, ina@axios.com. But thank you to the panel.
thank you.